Alright, Chapter 7, Part 2, Ionic Nomenclature. Remember, ionic is dealing with a metal and a nonmetal. Let's look and review what an ionic compound is. They form ionic bonds, meaning that they lose or gain electrons. Remember, metals lose electrons to become positive. Nonmetals gain the electrons to become negative. They have electrically charged particles. The positively charged metal is referred to as the cation. The negatively charged metal, or the negatively charged nonmetal, or negatively charged polyatomic ion for that matter, is called an anion. And like I said, it forms between metals and nonmetals. So let's jump right into ionic nomenclature. This is just an overview of the process. The best way to learn this, and this is what we'll do mostly in class, is practice. We will practice lots and lots of problems. So this is just an overview, kind of a how-to overview. Alright, ionic formulas. Remember, formulas contain symbols and numbers, and the names are just that. They're the names. So ionic formulas, how to get ionic formulas. You write each ion first, the positive one, or the cation first. Don't show the charge with their charges. Now, we won't show their charges in the final formula, but we want to have their charges first. Okay? Now, the overall charge must equal 0. If the charges cancel, like for example, if you have a positive 1 and a positive 1 cation and a negative 1 anion, those charges just cancel, so we do nothing with those. If they do not cancel, we use the subscripts to balance the charges. And the best way to balance the charges is just to take the charges and cross them. So take the charges of the cation, and that will be the subscript of the anion. And the charge of the anion will be the subscript of the cation. I know, it makes a little bit of sense. It's called the crisscross method, and we'll work on it in class. We must use parentheses to show if we have more than one polyatomic ion. Remember, a polyatomic ion contains many atoms in the ion. And we may have to use what is called the stock system. If you have a transition metal, one that's in the center block and a couple outside of the center block to the right of it, we must use what we call the stock system, or Roman numerals. Those Roman numerals indicate the charges of the metal, the transition metal. Alright, remember, transition metals, they're not like group 1 or group 2 or 13, 14, 15, 16, 17. We don't know those charges. The transition metals can have various charges, 1 to 6 or even up to 8. Alright, now ionic names. How do we determine the ionic names? Well, we always write the name of both of the ions. Always start with the cation, so the metal will come first. Then change the ending of a monatomic ion, or the second anion, to IDE. We always end in IDE if we have a monatomic ion. If we have a polyatomic ion, we have to go to the back of our pink-colored periodic table. I have given you a pretty good list of polyatomic ions in the back of that periodic table. And then again, we'll have to use the stock system. We use Roman numerals to show the cation's charge if more than one charge is possible. Now remember, our overall charge must equal 0. That way, we'll have to kind of use some of our deductive reasoning skills to determine Roman numerals sometimes. Roman numerals indicate the charge of the transition metal. Alright, let's consider the following about polyatomic ions. If it contains a polyatomic ion, or how do we know if it contains a polyatomic ion? Well, if it ends in IDE, it is not a polyatomic ion. It is a binary compound, so it has 2 elements. If it ends in ATE or ITE, then we're going to have to go to the back of our periodic table and look up the polyatomic ion. Now, the second question. Does it contain a Roman numeral? If it contains a Roman numeral, we need to determine if it's from group 1 or 2, because group 1 and 2 do not have Roman numerals. Okay? Only transition metals have Roman numerals. And in ionic nomenclature, we have no prefixes. We do not use monoditride, tetra, penta, we do not use any of the prefixes. We just use IDE or the Roman numerals if we have to indicate charge. Common ionic charges. Alright, group 1 has a +1 charge, and group 2 has a +2 charge, or 2+. These are the only metals that we know the charges of, with the exception of 3 more. Aluminum always has a +3 charge, zinc always has a +2 charge, and silver always has a +1 charge. So we have a little stair step there. We know the charges of these 3. Every other metal, we have to use the stock system, anything in here. Now, group 13 has a +3 charge for boron and aluminum. These metals are transition metals. Okay, transition metals. Group 14 rather, they have ±4. We don't use those in ionic bonding. Group 15 has a -3 charge, group 16 has a -2 charge, and group 17 has a -1 charge. Remember, noble gases typically are not used in bonding, so they don't have a charge. So let's practice. Sodium is Na, so we're going from formulas to the names, so we're having to write the names up. Na is the symbol for sodium. Br is bromine. Remember, sodium, bromine. The INE in bromine has to be changed to IDE because we're dealing with ions, so it will be sodium bromide. Alright, the next one. We have sodium, then we have a polyatomic ion. For polyatomic ions, we have to go to the back of our periodic table. If you look up CO3, you're going to see that CO3 is carbonate. So we end up with sodium carbonate. Alright? Now our third example, Fe. Fe is not in group 1 or 2. So that makes it a transition metal. Remember, we have to use Roman numerals to indicate the charges of transition metals. Alright? Now, how are we going to figure out what the charge is if we have a formula? Well, that's simple. We uncross our subscripts. Remember, we have an understood 1 here. So the 3 goes with the iron, and the 1 will go with the chlorine to indicate their charges. So we end up with iron 3 chloride. This tells us the charge of the iron. So let's go from names to formulas. Okay, we're starting off with potassium. We always write the symbol and its charge first. So we have potassium. Potassium is in group 1, so it has a +1 charge. And chloride. Chloride is in group 17. 17 has a -1 charge. What we have to do is we have to balance these charges. Like I told you, the easiest way to balance the charge is to cross them. So the plus comes down, the 1 comes down here, the 1 goes down there, and we end up with KCl. Alright, magnesium nitrate. Alright, magnesium is in group 2, so we're going to have Mg2+. It has a +2 charge. Nitrate. Well, it ends in ATE, so that means it's a polyatomic ion. We have to go to the back of our pink periodic table and look up nitrate. Nitrate, you'll see, is NO3. So we end up with Mg2+, because it's from group 2. And NO3, 1- because that's what the back of our pink periodic table tells us. Now, remember, we have to cross our charges to balance them out. So this 2 is going to come to the nitrate, and this 1 is going to go to the magnesium. Now, remember, with polyatomic ions, we have to use a parenthesis. We'll have to put a parenthesis around NO3 because we can never change polyatomic ions. Never, ever. So we end up with MgNO3. Copper 2 chloride. Alright? Copper is going to have a charge. Copper is a transition metal, so we do not know what its charge is going to be without looking at the Roman numerals. Chloride is in group 17, so we know that's going to be -1. So copper is 2+. Where did I get this 2 from? Right here, the Roman numerals. Okay? Now we have to balance the charges. What's the easiest way to balance the charges? We can use the crisscross method. We bring the 2 from the copper down to the chloride, the 1 from the chlorine down to the copper. We end up with CuCl2.